In this video, you guys are going to learn about list abbreviations. So there's a problem with cons, and that is that when a list gets big enough, right, this one has 10 strings, 10 names, right, you can see that the cons has this nested pattern and this staircase pattern. And all the ending parentheses for each individual cons, right, they're all bunched up at the end, right? So you need like 10 parentheses. All right, so let me copy and paste this into my editor. Not only is it hard to read, it's hard to type this out manually, right? You can imagine yourself doing that. And, let's say that you accidentally put a parentheses here, right? And you hit run. It's going to say that this ending parentheses is the problem when really it was here, right? So let's say you naively follow the error messages, right? And delete the ending parentheses and hit run. Well, it's going to say this is the error now. But it says cons expects 2 arguments only found 1. So you might think, oh, right, you need an empty here, right? Maybe that's the problem, and it's not, right? You can really go into spirals doing this, right? So I'm going to Control Z and undo all this and go back to the valid list like so. All right, so how would we fix this? Well, we can use the list function instead to write the same list. So I'm going to copy and paste this into the editor here. I'm going to come out with this cons list and paste in the same list using the list function to create the same list, right? So these two are exactly the same. In fact, if I run this, right, run this code, it's going to evaluate to a cons list, right? So these two are completely interchangeable, right? It's just that this one is much more easy to type and much more easier to read. But what if we want to see the same thing here, right? What if we want all cons lists to print like this? Well, what you would need to do is to change the language level. So to change the language level, you go to the bottom left corner over here, go to choose language, and then click beginning student with list abbreviations. So I'm gonna hit OK. And if I run this code now, it's going to print out in the list notation. Do note that this is still just a cons list. Underneath, it's still just a cons list, and I can prove it, right? So let me just delete all this code and write something like rest of list 5, right? So remember cons list, right? Cons 5 empty. This would be the equivalent of this, right? This list 5 and then this cons 5 empty. So this rest of list 5, right? Since this is a cons list, you're going to see empty, right? Because all cons lists have to end with empty. So even though you don't see an empty here, right? Again, all list, if you see this list format, it's still just a cons list underneath. So if I hit run, we're going to see an empty here, like so. And if I do a check expect, right? So let's say check expect list 5, is that the same as cons 5 empty? Right, we see that it's the same, right? This exact same thing. It's just a different notation of writing it. All right, so here's a table of the shorthand version, right? List ABC, and here's cons list ABC, right? The cons list version, cons ABC onto empty. Here's list false true, and here's cons false on the cons true empty. And here's list 1, 2, 3. And here's cons 1 on the cons 2 and cons 3 of empty, right? These two are functionally the same. They're completely equivalent, all right? And this is the struct version. All right. Now, when do you use cons versus list, right? Because you might be tempted to, always use list now, right? Yay, no more cons. I don't have to deal with nesting. But that's not going to be the case, right? Why? Because cons is good for building lists, right? So continuously adding things on a list, right? When you're in a function, sometimes you want to add things to a list, sometimes you don't, right? Sometimes you want to keep building and growing the list dynamically. You're going to use cons like 95% of the time in functions, right? So yeah, list is more useful when you're writing examples, right? Like these examples here, check expects, right? But most of the time, right, for cons, again, let's say something like list temp, let's say ls con empty ls, right? You're going to often write cons in recursive functions, right? So again, 95% of the time, if you see a list, if you're using a list, right, in a function like here, like so, it's probably wrong. There are a few exceptions and some problems, but nonetheless, you should be using a list in the examples more often now because it's easier to type. So now let's do some exercises converting between list and cons notation. So if you go to this website, I'll link it in the description below. I recommend you guys copy and paste these code blocks and try to fill out the answer to them to check your understanding. All right, like so. So I'm gonna go back to this page here. You're welcome to pause the video and look through the shorthand and longhand as a reference. All right. So fill in the ... and make the test pass. Right. So here are all the ... right, like so. And it says use cons and empty to form the equivalent of the following lists. Right, like so. So write the cons list of this, and this in these ... Pause the video. I'm gonna go over spoilers in 3, 2, and 1. All right, I'm assuming that you guys took a good swing at it. So now let's go over it together. So for this first list here, right, list 72135, the equivalent cons notation is gonna be cons 7 on the cons 2, on the cons 1, on the cons 3, on the cons 5 of empty, like so. So we just run this code up. Let me just comment out these because they're in the way and run it. The test should pass, and that is how you know if you're right. Right? Let's move on to the next one, right? So this one's a lot more involved, right? This list contains inner lists, right? Elements themselves that are lists, right? So the first element is a list with he and 0. The second element of this outer list is list it and 1. And the third one is Leo and 14, right? So to write the cons equivalent, right? This cons would be this outer list, right? So this outer list, right? The first element is list he and 0, right? So cons he, and then we need another cons for the 0 and empty, right? So that is this part done, right? But for this outer cons, we still need to continue with all the other elements, which are themselves lists, right? So the second argument to cons is going to be cons, and we're building the it list now, right? So cons it, and then cons 1 empty, right? So this settles this one, right, like so. But this cons, right, like so, it needs another argument, right? This cons only has one argument. This is the first argument, and this second argument continues the third argument of the list, right? So it's a lot, but it's what you got to do. Let's move on to the next one. So cons, right? So this is the third element now, which is itself a list. If it wasn't a list, you would just put 1 and then empty and you're done, right? But since it's itself a list, we'd do another cons, Leo, and then another cons for the 14 and empty, right? So that is this list done, right? But this cons needs to be needs a second argument, right? So this cons needs to have an empty, like so. And if we run, it passes. It's a lot more involved. Don't, fret too much if you got it wrong. It's a lot. Let's move on to the next one, right? So we have list 1. So this one is not a list, right? And then the second element is a list, and then the third element is a list as well, right? So the first element is a 1, and then the second element is a list 1, 2. Third element is another list 1, 2, 3, and this outer list contains all of them. So to write the cons equivalent, it's going to be cons 1, right? So that's that one done. Now we have to do these other ones, right? So cons, and then do another cons for the 1 and 2, right? And then this cons, right, needs to do another cons for this other one, right? Because it's a list. So we do another cons here, and this cons is going to do a 1, cons 2, cons 3, empty, right? That's the 1, 2, 3 done, right? But this cons needs an empty. So let's just stick that there. All right, that's a lot to type, but all 3 tests pass. And the key to doing this is you should probably start indenting whenever you see the elements, right? You see when I hit the 1 here, right? I indented, and then I'm done with the 1. And then this list 2, right? This is the start of it, right? But this is, actually the item itself, like so. But I keep indenting and, keep trying until it works out. But nonetheless, that is how you convert list to cons. Now let's keep going and do another exercise, but going from cons to lists, all right? So I'm gonna copy and paste this and do this in a new tab, all right? So fill in the dots, all these dots here, right? Use list to form the equivalent of the following lists, right? Like so. So pause the video and try to work through this on your own. I'm gonna go with spoilers in 3, 2, and 1. All right, I'm assuming that you guys took a good swing at it, so now let's go over it together. So we have this first one, right? Cons apple on the cons banana on the cons chestnut of empty. So to write the list equivalent, it's going to be list apple, and banana, and then chestnut. We don't need an empty here because it's implicit when we write this list function. So let's just run this code. Oh, I got to comment on all the other tests. And we see that we got it right. Let's move on to the next example. Right? All right, so we have cons, and then this first element is a list containing apple, and this second argument is another list containing banana and chestnut. And this empty over here, way off here, it closes off this first list. All right, so it's going to be list, and then the first one is a list containing apple, so this equates to this, right? And then this is a 2-argument list, right? 2-element list containing banana and chestnut, right? So list apple chestnut, and then that's pretty much it, right? We don't need this empty, right? Because it closes off the ending of this outer containing list, which contains 1, 2 elements. And this list also contains 1, 2 elements. It just so happens that those 2 elements are themselves lists. So let's just run this code, and we get a problem here. It looks like I did it wrong. Apple empty. Oh, banana. Whoops. So I did a typo here. It's banana, like so. All right, that was the issue. All right, let's move on to the next one. So we have check expect cons list 1, 2, and then cons list before, right? So remember what cons does. Cons puts this in front of this. So if the second argument is a list, we just put this in front of it, right? So let's just copy and paste this down. Right, so this mixes and matches cons and lists, right? You're not going to see this often at all when you write the actual code, right? But this is just an exercise to tease your brain a lot, right? So we have this, right? And we're putting this in front of this. So this is going to be inside this list, and this is going to be the outer list, right? So this should pass, and that is the third answer. Let's move on to the last one. All right. So we're going to put this in front of this. So let's just write this out in list format. So this, right, copy and paste it down below. And list format is just going to be list empty. We don't need this second empty because it closes off for cons, right? And it says to put this in front of it, right? So we're just going to put this in front of it here and convert it to the list format. So list empty. And then we don't need this closing empty because that's only just for cons. And that is the answer for this last one. A bit confusing, but I recommend you read up on what cons does and how it evaluates. Use the stepper to see the order of operations, like so. Anywho, let's move on to our last exercise, cons to list but with structures. All right, so I'm gonna copy and paste this into an editor over here, like so. All right. So pause the video and try to use list to write the equivalent list of these cons structures, right? So we have cons and they contain their list of structures, right? So here's Bob, Lisa, and Jack. So like so, we just run this off to the side, right? It will give you the answer. So try to not run this off to the side and write the equivalent list in these dots, except for the last one. The last one you have to write a value, but nonetheless. All right, I'm gonna go with spoilers. 3, 2, and 1. All right, I'm assuming that you guys took a good swing at it, so now let's go over it together. So for this first example here, right, the list containing Bob, Lisa, and Jack in cons notation, it can be written as list Bob, Lisa, and Jack. All right, like so. So we just comment on all these other tests really quickly and run this code, and we see that it passes, right? Let me just run this REPL all to the side here, and you can see that it evaluates to a list of persons, all right? Let's move on to the next example, right? Cons, Jack, Bob, and Lisa, right? So the equivalent for this in list format is list Jack, Bob, and Lisa, right? Like so. And then finally, this last one is not going to be a list, it's going to be a value, all right? So let's evaluate it step by step, right? The rest of this, right, will produce the list Jack, right? Because the rest, again, right, takes the rest of this list, right? And the rest of this list only has one element in it, so it's just going to be Jack. All right, so we have that. And then after this rest, is going to be your first. So we're going to take the first of Jack. First of the list Jack, right? So the first of this list, right, this list is going to be just Jack, right? The person Jack right over here. So that's going to be that. This evaluates to this, all right? And then this is going to be taken into person-lname. So the lname field of this structure is going to be Chan. So this should produce the string Chan. We should expect Chan here. And we do. So all three tests do pass. Anywho, final recap. In this video, you guys learned about list abbreviations and how to convert between cons and list abbreviations, like so. And how even though we have list abbreviations here, underneath there's still cons list. You also learned when to use cons and when to use lists, right? You're mostly going to use lists in examples, and you're not going to really use list in functions like so, right? So if you see this, most of the time it's wrong, but there are going to be some exceptions, right? I would say 80% of the time, if you're using list in a function definition, it's probably wrong. Anywho, that is about it for this one, and I will catch you in the next one.